Hello everyone and welcome back. Hopefully you tried example 4 on your own, and if you didn't, you need to go back and do it. So I did example 1 and example 3, and you need to do 2 and 4. Now for example 5, I'm not really going to walk you through it like I did the first two, because this one's one of my favorite proofs, and the first piece of given information is super important to help you finish this proof. So in this proof, it says that AD is parallel to CB. So I'm going to mark that AD is parallel to CB. It doesn't matter if the arrows are pointing up or if the arrows are pointing down. And I know that B to D to C, starting at B, D, so this angle right here, is congruent from D to B to A. So this angle is congruent to this angle. So all I have given you for example 5 is an angle. You still have to prove that the two triangles that says G, but that should say DCB. Is congruent to, oh, look at that. Let's just cross this off for a second. Triangle DAB. I remember typing this one. I thought it was funny. DAB needs to be congruent to BCD. So I need to prove that triangle DAB is congruent to BCD. And all I've given you is that parallel lines and these angles right here. I want you to think about what you know about parallel lines cut by a transversal. And I want you to think, well, why would these two angles be congruent other than the given statement? Again, we have parallel lines cut by a transversal. So you should be able to figure out that if those lines are parallel and they're cut by this transversal, something else about this triangle and this triangle, but more importantly, the parallel lines. And then see if you can finish this proof. I will not be going over the answer during this video, but hopefully if you know something about parallel lines, you can finish this proof on your own. For example 6, the flow chart proof looks different than all the other ones. It still has 3 up top with lines underneath. It has 1 below it, but then it has an additional one below that. So the 3 bubbles, again, mean one of your 3 triangle congruency statements, your theorems, and then the one down below is going to be my 2 triangles that are congruent. Now the reason that there's another one below is because this proof doesn't ask you to prove that the 2 triangles are congruent. It asks you to prove that 2 sides are congruent. So if I have my 3 bubbles up top to prove that my triangles are congruent, and I use a theorem to prove that they're congruent, then I know that the corresponding sides are congruent, which was again from that common vocabulary. So I'm not going to walk you through this one as well. As you can see, this one already has some information. It has TV is congruent to QS. It's already marked it. It said that angle V is congruent to angle S, and it has marked something else for you. I truly believe that you can complete this triangle congruency proof on your own. And then for this last bubble, what you're going to write in that last bubble is what you need to prove. And so what I need to prove on this one is that VR is congruent to SR. And the reason that they're congruent, if you look at that common vocabulary again, it's there. We will go over the ones that we didn't do together in this video, but please make sure example 1 and example 3 are complete. By doing those 2, you should be able to complete number 2 and number 4, no problem, as well as number 6. Number 5 asks you to extend your thinking by only giving you an angle, but giving you those parallel lines gives you something else about parallel lines cut by a transversal. I hope you guys have a good day. Don't forget to do your Delta Math assignment, and I will see you tomorrow.